Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afandi bin Muhammad KHUSRIN. My matric number is DE110109. In this video, our group will explain about the first activity in MEK laboratory, which is voltage source inverter with 120 degree and 180 degree conduction mode. Okay, for the introduction, an inverter is used to convert the AC power to the DC power. Where, for example, when we want to use the DC power equipment, so we only have AC power, we need to use the inverter to use the DC power. So from the AC power, the inverter will convert the AC power to the DC power. Okay, the example of the inverter is voltage source inverter, which is VSI. This inverter is mostly used in a AC drive motor. So this figure shows the example of voltage source inverter configuration. So this is an example of VSI. So the VSI will operate in two conditions, which is 180 degree conduction mode and the other one is 120 degree conduction mode. So between these two degree, it has several differences. Okay, first of all, for the 180 degree, the switching can be connected either positive and negative. Next, the currents always in a continuous condition. Okay, for the 120 degree, the connection is suitable for the delta connection load, and it will show 6 type of waveform at each phases when it running. Next, the objective of this lab activity is to simulate the VSI with a pure recessive load for mode 180 degree and 120 degree and obtain the corresponding waveform using a MATLAB simulink. The next objective is to analyze the output from VSI with specific input voltage. The last objective is to understand different types of VSI and their respective working principle, advantages, disadvantages, construction, switching techniques, and application.
Hi, good day to Doctor and my team member. I will present about the result and discussion for VSI 180 and 120 degree conduction mode, inverter design and simulation for this presentation. Let's begin. For this MEK activity 1, we have designed 180 and 120 degree conduction mode voltage source inverter. The first one here shows 180 degree conduction mode of VSI, and second one is 120 degree conduction mode voltage source inverter. For this lab, we have used the MOSFET transistor for switching component in VSI inverter, and for the 180 degree, we adjusted the PWM signal phase delay for 180 and also 120 phase delay for 120 VSI. Then for this simulation, we have used the discrete type power GUI specification with the time of 0.05 millisecond. Then the parameter we set for the input voltage, which is 250 voltage for both 120 and 180 degree VSI. Then the output resistance is 10 ohm of resistor only for both 120 and 180 VSI. In addition, for the simulation time, we set to 0.4 millisecond for both VSI. Then we placed a measuring component, which is base voltage measurement and line voltage measurement, as well as switching signals for both VSI. So after that, we will run this simulation to obtain the graph of switching signal, base voltage, and line voltage of each of the 120 and 180 conduction VSI. Let's see. From this output graph shows that switching signal T1 until T6 of 180 conduction voltage source inverter. From this simulation waveform identified that each of the switching signal conduction from 0 to 180 degree as theoretically stated. In addition, it was discovered that only one switching signal is active in each of the three segments. This graph shows that switching signal T1 until T6 of 180 degree conduction voltage source inverter. From the simulation waveform identified that each of the switching signal conduction from 0 to 180 degree as theoretically stated. Then for the 120 degree BSI switching signal will show in this graph, which is from the simulation waveform identifies that each of the switching signal conduction from 0 to 120 degree as theoretically proven. Then this is the line voltage and base voltage as shown in figure 1 and 2 for the 180 conduction mode voltage source inverter. In this both figure 1 and 2 show the line voltage and base voltage waveform of 180 degree conduction VSI. The line and base voltage is displayed in data tip is low due to consist of resistance in MOSFET transistor since the simulation setting is not ideal. As shown figure 1, line voltage obtained peak line voltage of 247.524 volt, almost equal which is applied 250 voltage DC source. In graph show the line and base voltage shifted with 120 degree with each other phase. Then we will observe the output voltage and line voltage for 120 degree conduction mode. Let's begin. In figure 1 and 2 show the line voltage and base voltage waveform on 120 degree conduction voltage source inverter. The line and base voltage as displayed in data tip is low due to consist of resistance in MOSFET transistor since the simulation setting is not ideal. As shown in figure 1 and 2 obtained peak line voltage of 247.524 voltage, whereas for the base voltage obtained 123.762 volts. In addition, in graph show the line and base voltage shifted with 120 degree, which is other phase same like 120 degree conduction mode VSI but with different voltage amplitude. Finally, I will add the discussion part for this presentation. As mentioned in the early part, either 180 or 120 degrees conduction mode voltage source inverter switches will active only one in each segment out of three segments. Then there are two sorts of control signals that may be utilized to manipulate the three-phase inverter switch. They are conduction angles of 120 and 180 degrees. In order to obtain the correct output of three-phase AC signal, each requires various properties. As the name suggests, in the 120 degree conduction mode, each switches conduct for 120 degrees, whereas in the 180 degree conduction mode, each switches conduct for 180 degree. The number of switches that remain on at any given moment is an advantage of 180 degree conduction over 120 degree conduction. It is 3 switches for 180 degree conductivity and just 2 switches for 180 degree conductions. The load that may be linked to varies as well. Only a star connected load can be used for 120 connection. However, in the 180 degree conduction mode, both star and delta linked loads can be applied to the inverter. However, 180 degree conduction has one minor drawback, which is the switches on any one leg of the inverter cannot be turned on at the same time. Otherwise, a short circuit across the DC link supply would result. Despite this, the 180 degree method of conduction is favored and employed in three-phase inverters because the switches are used more than in the 120 degree form. That's all from me. Thank you. I will pass my next presentation to my team member.
For the conclusion, first, students were able to understand and simulate the connection of voltage source inverter VSI in MATLAB Simulink and analyze the data from the output signal. Second, The output signal shows the switching signal, line voltage and phase voltage in 180 degree and 120 degree of conduction mode. Next, in the switching signal for 180 degree conduction mode, there were 3 total MOSFET in on condition at each state when the circuit was running, while for 120 degree conduction mode, there were only 2 MOSFET in on condition at each state. The 180 degree conduction mode show the different value in phase voltage and line voltage, while in 120 degree conduction mode, it has the same value for phase voltage and line voltage. Overall, 180 degree conduction mode required a dead time mode between 2 switches in one leg, while 120 degree conduction mode no need requirement of dead time mode in one leg. That's all from us. Thank you.